Hey, good morning. I am Mike McKee. I am the Associate Director for the Photonic Science and Engineering Program, and I'd like to welcome you for spending some time with us to learn about photonics. I've also got with us Dr. Peter Delfyett, who is one of the scientists in the College of Optics and Photonics at UCF, and he's going to be up first talking with you in a little bit. He also teaches in our undergrad program. And then I've got Dina Floridor, who's from our UCF Admissions office, and she's got to have some information for you about admissions, and you might have questions about how do you get into UCF. And then finally, we're going to be talking with Brandon Triplett, who is one of the students in the Photonic Science and Engineering program, and I believe is like getting close to graduation. So we'll have some information to share there. So first up, what I want to do is introduce Dr. Delfyett. And if you do have any questions, sort of queue those questions up. Those of you who are in the Zoom meeting room with us, you'll have an opportunity at the end to ask some questions live with him or any of us. And then those of you who are watching on YouTube, go ahead and put your questions into the chat room, and then we'll get to those as we can. So we'll go to Peter first.
Excellent. Thank you, Mike. Let me share my screen here. Very good. Good morning, everybody. As Mike was kind enough to announce, my name is Professor Peter Delfyett, and I'm one of the faculty here at Creel University of Central Florida. I've been at UCF for about 27 years, and prior to that, I worked in industry at Bell Communications Research, where we worked on photonics technology for the fiber optic network of the future. So let me tell you a little bit about the photonics program and effectively what photonics is in some sense. So the easiest way for me to describe photonics, I'd like to make a simple analogy, is that if you think of electricity, which is what we all know and love and power our homes with, electricity is carried by electrons, and then we build technology based upon electrons, which we call electronics. In the same way, light, just like electricity, is nothing more than electromagnetic waves, but the carrier of light is the photon, and then we build technologies based upon that, which we now call photonics. And in some sense, photonics is the new engineering. In many universities, you have chemical engineering, electrical engineering, computer science and computer engineering, mechanical engineering, aerospace engineering. Well, photonics and photonic science and engineering is basically this new field that UCF has been pushing for maybe about the past 3 decades. Now, we've in fact developed our program based upon what I call the three-legged stool, where students will learn about the different types of optical materials, whether it's glass or semiconductors, liquid crystals, nanomaterials, etc. And based upon the optical and how light and photons interact with these materials, we are then able to develop new types of devices which will exploit this light-matter interaction. And these devices we then incorporate into different systems. And some of these different applications I'm basically showing you on this view graph. These applications relate to anything from literally energy conversion, solar cells, lighting and displays, biomedical industries, fiber optic communications, the internet and the cell phone, laser-based manufacturing, etc. So some of the key areas in photonics engineering is the development of lasers, new types of imaging, sensing, and displays, the development of what we call not just electronics, but optoelectronics and photonic integrated circuits. We have fiber optics, which is powering the internet along with optoelectronics. And we have some new areas, which we'll call quantum optics, and that's what is garnering a lot of attention these days when people are talking about quantum encryption and quantum computers. So now, I'm just going to highlight some of the different types of technologies that photonics enables. you should recognize that photonics is an enabling technology, and it is literally in every facet of human life today. And what I'm just showing you here are just some simple, images of how photonic technologies are utilized in areas related to imaging, biophotonics, etc. And so today we have the ability to literally not just image cells, but literally image inside cells where we can effectively watch in real time the functioning dynamics of how cells operate. This gives us unprecedented resolution and the ability for researchers to literally understand more about the workings of the human body, etc. And it's this type of technology which folks are looking at in terms of trying to figure out, what this new coronavirus is all about. And so there are many students which are focused on biophotonics research. And again, I just wanted to highlight this particular area as one area in which this imaging, display, and sensing technology can be applied in, measurement systems, sensing, biology, medicine, and literally the displays that you're looking at right now. One particular example I would like to point out is that one of the technologies that has come out of UCF and the UCF students is a company called Luminar, which has just partnered with Volvo, who is a major automobile manufacturer, to utilize laser ranging and imaging to enable the autonomous vehicles that will be driving on the roads in the near future. So again, at UCF, we're just not training students to become the next generation photonic science and engineers, but we're developing technologies which are literally being started by UCF students and coming and utilizing UCF technologies, which are making tremendous impact in society worldwide today. Another example I'd like to point out is this business of fiber optics. And what I'm just showing you here is a couple of pictures of some of our faculty standing next to these fiber draw towers. And these fiber draw towers are these devices or systems which literally pull and make the fiber optic cable that is powering the internet today. So up in this particular view graph, I'm showing you an end-on view of what a fiber optic cable looks like. And this little spot here is where the light is carried. This spot here is on the order of maybe a 10 micron diameter, but literally can carry as much information as about 1 million Netflix channels simultaneously. This is about 5 trillion bits of information per second. So this is the standard types of fiber that we have today. But what we're doing at UCF and in Creole, we're developing fibers with new types of internal cores where, let's take a look at this example. Instead of just having one pipe to carry information, here we have 20 individual light pipes in one cable that are literally carrying 20 times as much information as a single fiber could carry. And it's this type of technology that the world has invested in that has enabled the internet technology of today. And again, this type of technology is useful for fiber optic communications, data networks, etc. So what I'd like to sort of point out is this particular little cartoon I have here, which is just showing you the, in blue, the number of undersea cables that are typically installed by companies like AT&T and Verizon, but the ones highlighted in yellow are the more recent ones installed by companies such as Microsoft, Facebook, Google, and Amazon. More importantly, what's not shown here is the tremendous investment in the terrestrial fiber backbone, which would have, yellow and blue lines, traversing all across the different countries. And it's this type of technology that is enabling multiple users to participate on Zoom conferences, users on the order of literally hundreds to thousands. And I'd like to mention that if the globe had not invested in this type of fiber optic technology, all of the sort of online teaching and technology that we have today that we're utilizing that is enabling us to get around this, lockdown and coronavirus. We would not be able to have those technologies today if we did not invest properly in this technology a few decades ago. And it's because of that investment. This is why photonic science and engineering has become a critical tool in today's global economy. Now, in addition to that, in addition to just supplying the fiber optic network, we also teach students about a field which we call integrated photonics and optoelectronics. And this is where the photons meet the electrons. And so what we do there, students are basically learning about, new types of semiconductor materials, nano types of materials, quantum dots. These are all interesting vocabulary words, but the point is what I'm trying to make is that, we utilize similar types of manufacturing and fabrication technologies that are typically common for producing the integrated circuit chip, but these integrated circuit chips now have photonic technologies on them. Things like semiconductor lasers, modulators, photodetectors, filters, etc. And it's the combination of the electronics and the photonics that enable devices such as shown here, where the electrons are still performing functions like switching and memory, but it's the photons or the photonics or the light waves which are doing the transport. And to give you a feel, let me go to my next view graph, to give you a feel what we're literally talking about, a few years ago, if you went into a data center, what you'd see are racks of equipment where each one of these little yellow things is a single optical fiber. This thing looks like a rat's nest, but we're now able to take technologies like this and integrate it on photonic integrated circuits such as this. And one particular program that I am working on right now, funded by the Defense Advanced Projects Research Agency, is we're basically cramming 5 terabits of information on a semiconductor chip about the size of the head of a finishing nail, 1 millimeter squared. So we're processing 5 trillion bits of information per millimeter square. We're developing chips that look like this. These chips will then be incorporated into the data centers of the future. And with things like this, instead of us viewing each other on simple 2-dimensional screens in our laptops, this will literally enable things such as the Star Trek holodeck, where we'll sit in our offices at home. The walls, the floors, and the ceiling will be paneled with, organic liquid crystal displays. These displays will be typing in 3D type of visual imagery, and we'll be able to think we're sitting on the beach, even though we're sitting in the comfort of our homes, enabling distance learning and conferencing such as what we're doing today. So at this particular point, hopefully I've been able to give the audience a little bit of a perspective in terms of what this new engineering of the future is, photonic science and engineering. I'd be happy to take comments and questions, but my last comment is for those folks which are pursuing photonics and light-enabled technologies, these folks have seen the light and know what the future has in store for them. Thank you very much.
Thanks, Peter. Hey, I got a question real quick for you. This comes from Paul, who's watching on YouTube. It says, how is photonics being incorporated into Industry 4.0? Do you know what 4.0 is?
Industry 4.0, no. I don't know if he's referring to next generation type of wireless technology, but Industry 4.0, I'm not familiar with that particular terminology. If Paul it has the ability to give me a slightly better definition, I'm more than happy to address that.
Okay, great. Well, and I'll watch for that, and then we'll come back to you at the end if he's got clarification. That was fantastic. I actually learned some additional stuff on him. Oh, okay. He actually responded back. He says it's the Internet of Things. How is photonics being incorporated into the Internet of Things?
Oh, sure. So Paul, let's think of this. The Internet of Things is the concept that everything will be connected to the internet. There will be sort of artificial intelligence which can effectively sense what's going on and effectively communicate to the user, perhaps yourself, your industry, and try to be more proactive in terms of keeping things, robust and running. One particular example that I love to talk about when we talk about the Internet of Things and next generation wireless and what will ultimately be referred to as Li-Fi, not necessarily Wi-Fi. I think we all are familiar with what Wi-Fi is, but Li-Fi is the idea of having, instead of wireless connectivity, things are going to be connected instead of using radio frequency waves, things are going to be connected using light waves. And what we'll see is that in our offices, we'll have, LED lighting, which will be, in the ceilings and in every light fixture. But to us, these lighting devices will just be providing ambient light, in the red, green, and blue portions of the spectrum. But in reality, these light or LED devices are going to be blinking on and off at rates of billions of blinks per second. And it's this blinking of the lights which are going to be providing, the information to our autonomous devices that will then be connected to the internet. So photonics will be playing a role in terms of having devices that are not just sensing everything around us, whether it's our biological health, whether it's our heart rate, blood pressure, glucose level, oxygen content in our blood, if we're sort of, not feeling well, and then being able to type this information around to perhaps your family doctor to, let him know that maybe you're not doing well. These devices are perhaps, in your house sensing the temperature, adjusting the temperature on lighting levels to provide comfort to your home. So literally, it's the photonic devices, both providing in sensing, display, and transmission of information that is literally making the Internet of Things the reality of today and of the future. So photonics is literally the underlying technology that is enabling the Internet of Things to become a reality.
Excellent. Thanks so much, Peter. Up next, we're going to have Dina Floridor, who's from the UCF Admissions office. And while she's getting set up, I just want to share that on May 16th, which is this Saturday, is the International Day of Light, which is an annual celebration. And SPIE, if you search for SPIE, which is an international organization of optics and photonics, and International Day of Light, you will find their website, and there's a lot of resources available with lesson plans that can be downloaded and other activities going on. So with that, I'll go over to Dina, who's got information to share about UCF Admissions.
All right, hello everyone. I hope everyone's doing very well. So I'm just going to go over the admissions process to UCF for both freshmen and transfer applicants, as well as some information about scholarships and just a general timeline of the admissions process. So let's go ahead and get started. Generally speaking, with admission to UCF, we do like to advise that students begin the application process early. So for our incoming freshmen, our current high school students, this looks like about the fall of your senior year, so between September to November. Now, as far as transfer students, about 6 to 9 months prior to the term that you wish to enroll for, just kind of depending on your transfer admission status, and we'll go into that in further detail in a little bit. And some advantages of applying early. First and foremost, here at UCF, we are on a rolling admissions basis, which means that there isn't one set date or deadline where we're required to roll out admissions decisions all at once. It's an ongoing process, and we're making decisions throughout the application cycle. So essentially, as soon as your file is complete, it goes to the committee to review, and we can get you a decision right after that review is complete. Another advantage is scholarship opportunities. For our freshman applicants, you're automatically evaluated for merit-based scholarships from our office, and our transfer students are eligible for scholarships as well. But essentially, the sooner you apply, the sooner you can be considered for these scholarships. And then last but not least is housing options. There are about 12,000 beds in total on campus, and you can't apply for housing until you've been admitted. So essentially, applying early gives you sooner access to those different housing options. And our application deadlines are on the screen, and these are our absolute hard set deadlines. But again, you want to be applying well in advance of these dates. So how to apply? First and foremost, of course, we need a UCF application. Our freshman applicants, you can apply via our website, the UCF institutional application or the Common App. We don't have a preference on which one you submit. We just ask that you don't submit both. And if you're submitting that online, you do have the option to go ahead and pay the $30 application fee while you're in the application form. Otherwise, if you qualify for any waivers such as SAT, ACT, or NACAC fee waivers, we'll accept those as well. Then you're going to want to send in your official transcripts. For our high school students, we do need an official transcript sent directly from your high school. We don't do SSARs or self-reported grades. Unfortunately, it does have to be an official transcript. But once we receive that, we're going to go ahead and recalculate your GPA based on your academic core classes. So this is going to be your math, science, social studies, English, and your foreign language courses. We won't take into account any electives unless they're an academic elective. So if you take an extra math class or an extra science class, we'll count that in your GPA. But for things like drama or music, unfortunately, we won't factor that into your UCF recalculated GPA. We do give extra weight to any academically rigorous courses, however. So if you take any AP, IB, ACE, or dual enrollment courses, we'll give you an extra point on your GPA. And for any pre-AP, pre-IB, pre-ACE, or honors courses, we'll go ahead and give you an additional half point on your GPA. So essentially what that looks like is if you take AP biology and you earn an A, we'll give you a 5.0 on a 4.0 scale. And if you took honors English and you earn an A, we'll give you a 4.5 on a 4.0 scale. So that's kind of how that works there. For our transfer students, we do need an official college transcript from each and every institution attended. Even if you only went there for one semester, even if you only took one course there, we do need an official transcript from each institution attended. And we're going to go ahead and recalculate your GPA based on UCF's grading scale. Our quality points may be awarded differently from your university, so we'll go ahead and recalculate it based on our scale. And if you have any less than 30 college credit hours, we will still also need your high school transcript on file as well. Now, as far as standardized test scores for our incoming freshman students, we do need an SAT or an ACT score on file. We don't have a preference for which test that you take. However, we do recommend that students sit for both just to kind of see which test they do better on. For the SAT, we'll super score. So we'll take the highest math and the highest critical reading of all the sittings that you've done, and we'll combine that to form your super score. For the ACT, we would just take your highest composite score. And then last but not least, of course, is the essay. It is not required, but it is recommended. We do have a few prompts on our website. You're welcome to also follow the Common Apps prompts, or if you just wanted to submit your own personal statement, we'll also take that as well. All right, so this on the screen is our freshman class profile. So this is what the credentials that the admitted students had for the fall of 2019. So we had just about 32,000 applications, and we admitted just under 13,000, and about 3,800 enrolled for the fall semester. Now, our class averages are what you will see on the website. So I really want to draw your attention down to the mid-ranges at the bottom of the screen. This will tell you what the middle 50% of students earn to be admitted to UCF. So keep in mind that 25% of students scored below these numbers and 25% of students scored above these numbers, and they were still admitted to UCF. This will kind of give you a good idea of what would be considered competitive. Now, again, we are on a rolling admissions basis, so we'll always take new updated information that you have. So if you retake your tests later and you get a higher score, you're always welcome to submit that new information, and we'll always take that into account. Now, freshman applicants who apply for the fall semester, it is our most competitive semester. So we do also automatically consider you for a spring or a summer term as well. So if you aren't quite as competitive for the fall semester, you may receive a spring or a summer offer. Now, we do have a guarantee of admission called the Top 10 Nights program. It guarantees admission for high school students who are in the top 10% of their senior class. Now, it guarantees admission to UCF, but it does not guarantee admission for any one specific semester. That still does depend on the competitiveness of your application. And it also guarantees on-campus housing to these students as long as they apply for housing by May 1st. And there are a few qualifications for this program. First and foremost, you must currently attend a Florida high school. You must, of course, rank in the top 10% of your senior class, or if your high school does not rank, say, for example, you're homeschooled, we'll also take a UCF recalculated GPA of 3.9 or above. Then as far as minimum test scores, we're looking for at least a 1090 SAT or a 21 ACT, and then you must successfully complete 4 units of academic core math by the end of your senior year. Now, if you meet all of these qualifications and you have your application and all supporting documents in by January 15th, you are guaranteed admission to UCF, and you'll be notified of this by March 1st. All right, So transferring to UCF, first and foremost, I do like to give the disclaimer. If you are currently in high school and you are taking dual enrollment courses, you may even be earning your AA. That is great news. However, for admissions purposes, you would still apply as a freshman. A transfer student is defined as having completed 12 credit hours after high school graduation. So if you don't meet that criteria, you would still just apply as a freshman. Now, our transfer criteria is fully outlined on our website, so I would encourage you to visit there to kind of see the specific details. But generally speaking, the transfer criteria that we're looking for kind of changes depending on the number of credit hours that you have. Essentially, the more college credit you have, the less we're looking at your high school transcripts and test scores. Also, if you are earning an AA degree from a Florida public institution, you're not subject to the same kind of admission standards, only because we do have the articulation agreement with the state. So your admissions criteria kind of differs a bit, but you do receive admissions preference. Similarly, we also have what's called the Direct Connect to UCF program, which is a guarantee of admission for transfer students who earn an AA degree from any of our 6 partner institutions. All right, so scholarship opportunities. So we do have a few merit scholarships that we award from our office. For our freshman applicants, there is no separate application required. You're automatically evaluated. Now, these awards are based on your academic credentials and timing. Because they are merit scholarships, they do tend to run pretty competitive. So those mid-ranges that I showed you earlier, you're going to want to be on the upper end of those mid-ranges to be competitive for a merit-based scholarship. And then also your timing. As I said before, you want to begin the application process early because this scholarship funding does tend to run out pretty quickly. And the sooner you apply and are admitted, the sooner you can be considered for these merit-based scholarships. Now, our transfer students, we do have a few scholarships available as well. These do require a separate application that typically opens up in early spring, and they're due by about mid-April. And to qualify for one of these scholarships, you must be earning an AA from a Florida state or community college, and you must be planning to enroll at UCF for the fall semester. Now, because we are a public institution, we do accept other forms as well. Other forms of aid as well, including Florida Bright Futures, Florida Prepaid, any outside scholarships that you may have. Here at UCF, we also have what's called A2O, or Access to Opportunities. It's essentially a scholarship search engine that works a lot like FastWeb, if any of you have heard of that. Essentially, you go in and enter in all your information, and it'll auto-populate scholarships that you qualify for. Now, I have 2 timelines here, one for freshman, one's for transfer, just to kind of guide you in the admissions process to getting here to UCF. So first and foremost, our current high school seniors, again, you're going to want to be applying between September to December of your senior year. That's when you're going to want to begin the application process. Go ahead and take or retake the SAT and ACT, submit your application. We encourage students to begin their scholarship search early. The FAFSA, which is the free application for federal student aid, opens up on October 1st. The UCF priority date to complete the FAFSA is December 1st. So that's when you're going to want to have your FAFSA in and make sure that you're being considered for the most aid that you qualify for. Essentially, that fall semester is also when you want to begin exploring your college options. So we recommend that students visit us for a campus visit, a campus tour, or an open house event. All things, fingers crossed, going well, you should be able to visit us very soon. But again, just to kind of get a feel for campus. Now, once you submit your application and you are admitted to UCF, you do have some time to give us a final decision, and you would do that by way of your enrollment deposit, which is due by May 1st. Once you submit your enrollment deposit, you'll be able to go ahead and register for and attend orientation. And this is when you actually register for classes, you meet with your academic advisors, you get your UCF ID, and really get acclimated to becoming a UCF Knight. Now, the last step that students often forget about, between June and August, you're going to want to make sure that you submit any final documents to UCF. So your final high school transcripts, final dual enrollment or college transcripts, your test scores for any AP, IB, or ACE exams. Go ahead and send us in that final information so that we can give you credit for the credit that you've earned. All right, and then for our transfers, you can begin planning out the transfer process as soon as 2 years in advance. If you know right away you want to start off at a state or community college, go ahead and begin mapping that out, especially if you know you are at a direct connect institution. Go ahead and meet with your transfer advisor to make sure that you are on track. Now, as far as beginning the application process, you're going to want to start that process at least 6 months in advance. Go ahead and submit the application and application fee. When you renew your FAFSA, make sure that UCF is listed as one of those institutions. And again, that priority date is December 1st. And then, of course, after you're offered admission, you go ahead and send in your final transcripts to UCF, attend orientation, and sign up and register for classes. All right, so I know I covered a lot of information and I talked a little bit about visiting us for a campus tour or an open house. Of course, those things are not entirely possible during the moment. So we do have a lot of virtual options for you to just kind of explore campus, get to know a little bit more about UCF and, answer any questions that you may have about the admissions process. You're welcome to explore our website as much as you can. We have video tours of campus, the information that I just covered all over our website. So. And then also we are working remotely. So if you do have any questions that you aren't able to get answered today, we do encourage you to give us a call or give us an email, and we'd be happy to go ahead and assist you from there.
Dina, thanks. Okay, so of course your part has got a lot of questions. So I'm going to go first to somebody in the chat or in the YouTube chat, and then we're going to go to Johnston, who is in Zoom. So he's going to be asking you directly within Zoom. But the question is, it looks like we got that. Oh, here's the question, which is really going to be one for me, I think, is CJ asked what science math classes should be taken as a high school student. If it's for photonics, make sure you're taking physics, chemistry, and then get as much math completed as possible. So, if you can take the AP calculus class, that's going to be a big benefit. And by the way, not just taking it is important, but you must also do well in these classes. So make sure you do well. And of course, a higher GPA makes you more competitive, as Dina showed. Okay, let's go to Johnston, who's got a question for you.
Question: is TOEFL a must in case of an applicant whose language of instruction is English? So really, it just kind of depends. So if you are an international applicant or an applicant who English isn't your first language, there are multiple different ways to, prove that English proficiency. So if you don't have a TOEFL score, there are also other components that we may look for. One of the things that I recommend to students, if you are a freshman applicant, the SAT and the ACT is required no matter what. And if you have a certain score on the SAT and the ACT, we'll accept that in place of the English requirement. So I would recommend that you take a look at our website, because the specific score that you need on the English section of those tests will also qualify for that English proficiency requirement.
Okay, and then Kala Henry's got a question.
Does UCF have a website?
Have a website where we can compare our GPA and recalculate it ourselves?
So as of now, there is not a specific recalculation GPA, but essentially, as I said before, it's pretty simple to kind of go in and award that additional point if you have any academically rigorous courses. So of course, if it's an AP, IB, or ACE, go ahead and add that additional point for whatever your grade is. So if you earn a B in an AP class, whereas for a regular class, it would be a 3.0. You can go ahead and add that 4.0 on there, and that's what that kind of course requirement or course quality point would be.
Thank you so much.
Is there a general website though that we've got where they can add in their, their GPAs and have it calculate based on credit hours they've taken and then credit hours that they're, maybe still have in progress, where it could be done manually on their part?
Not that I know of, as far as our office, but I can definitely take a look and find out, do some research, if there might be that resource available.
Okay, and then Stephen's got a question from YouTube. Will we be required to submit official transcripts prior to course registration in order to transfer dual enrollment credits or AP IB credits?
So we won't need an official transcript until after you've graduated high school, but it may be something that you want to make sure that you have turned in by the time of orientation, just because that's where you go through and select courses. So you want to kind of account for the courses that you've already completed, so you're not duplicating anything. So I would say yes, to have those transcripts on file before orientation.
And then one final question from Vicky, also on YouTube. Do you get that extra point for dual enrollment classes? So I think that's maybe the weighted GPA.
Yes. Yep. For any AP, IB, ACE, or dual enrollment, you get an additional point.
Oh, okay. Very good. All right. Thanks. Stay tuned because there might be more questions for you. And then I'm going to now talk a little bit more about the Photonics program, sort of mirroring with what Peter talked about. And I'm going to share my screen. And Peter did such a fantastic job that I want to sort of jump to one part of my presentation. And what he mentioned is that optics and photonics, we call an enabling technology because it's used across a wide range of industries. And there are companies that do not necessarily call themselves photonics companies that hire photonics engineers. The reason I'm pointing this out is because the question that we get is, well, what can I do with a degree in photonics? Well, in fact, there was a report that was done, oh my goodness, about 8 years ago. And it's estimated that about 10% of the national economy or the world economy is based in optics and photonics. So here's where we stand. And this is one of the reasons that we're doing this Zoom YouTube live stream today, is that we're trying to get the word out that photonics is a really important field and that companies need photonics engineers. So nationally, the US Department of Labor forecast that we need about 1,200 new engineers to be hired every year. Now you consider, 1,200 new engineers and you see 470 in the state of Florida, it doesn't seem like a lot, does it? However, there are only 6 universities in the United States that have a bachelor's degree in either optics or photonics. And the combined number of graduates per year from those 6 universities total between 80 and 100. So even just the number of graduates out of the United States colleges per year don't equal the total that are needed within the state of Florida. So that means that really companies are chomping at the bit to get a hold of the graduates that come out of the universities that have this degree. And you see some other numbers here, like the average starting salary. So I want to point this out. This is really complicated, but I want to point out that the degree you select has implications on availability. So if you think, oh, look at these green lines, and the larger green line means, oh, this is much better, right? Okay, well, the green line actually stands for underemployment. You've heard a lot about unemployment. This is the number of people actively looking for a job, but underemployment measures you get a degree in a particular field. Do you get hired into that field? Well, if we go look at criminal justice, nationally, about 75% of students that get a criminal justice degree don't get hired into criminal justice. But way down at the other end, if you look down here at these jobs that have got low unemployment, like nursing, elementary education, industrial engineering, civil engineering, chemical engineering, computer engineering, general education, electrical engineering, mechanical engineering, you start to hear something in common. They're all engineering or they're education. So they fall into the STEM fields or education. Now, by the way, I neglected to say photonics in that list because we just don't have a lot of students that are graduating from this field that then get measured in data sets like what comes out of the Federal Reserve Bank. But you see here that these are low underemployments, which means most people that graduate with a degree in STEM end up getting a job in the field. And then if you look at the starting salaries, you see these low points. Well, the low points in salary, which is way over here, about 35,000, these refer to the education jobs. But the high points are in engineering. So is engineering a tough degree? Yes, it is. Students that are in the field of photonics or other engineering majors have to work very hard to get their degree. They have to give up, they'll have to sacrifice during their time in school. So that means, while your friends maybe in another major may be having to go out and have fun on some evenings, you may have to study, but it gets paid off at the end. And in fact, it is the engineers that are enabling even just what's happening right now with the response to the COVID virus. That what Dr. Delfyett talked about is they have enabled the ability to work from home because they've built the fiber optic networks, they've built the high speed capacity. You know, you also have in the STEM field, like doctors and nurses that are also developing the cures, they're saving our lives. So when you get into a STEM field, it really pays off at the end, but it's hard. That's okay. You have to work, but it's okay. So as I mentioned, we're one of only 6 in the nation. Now we are a joint program with the College of Engineering and Computer Science here at UCF. And if you follow these things, we are also ABET accredited. In fact, we're actually going through an ABET accreditation process right now. Our students do have to complete 128 credit hours. One of the questions that was out of the room, the YouTube chat was, you know, what do I need to prepare? Well, when you come in to the degree, and if you're going to follow either Photonics or you're going to go ahead and pursue any other engineering degree at UCF, you're initially going to be put into a pending, and you'll need to complete Calc 1, Calc 2, physics, and chemistry. The chemistry requires that you have chemistry in high school. So that's why I mentioned the chemistry class. And then if you do have AP or IB credit, then this can help satisfy some of the requirements here so that you can go a little bit faster in the major. Now, what I want to say there is that let's say you take the AP calculus, I think it's B, I don't remember. Anyway, let's take the AP calculus test, right? If you get a 3, the math department sort of considers that a little bit equivalent to like a D or an F. So if you get a 3, when you come to UCF, we're going to recommend you probably take it over again. If you've got a 5, you're going to be good to go. You want to be super strong because the calculus provides the foundation and the language that is used in the engineering classes. So in those basic physics and calculus classes, you want to be very, very strong. And then, of course, our students then go into an engineering core because they're working in photonics, which is the intersection of light with electronics. And then they get into the foundations of photonics, which is the first major course in our major, followed by about 45 credit hours of coursework, followed up with a great project-based class, Senior Design 1 and 2, in which they have to come together as a group. They have to come up with a project. They got to design it. They've got to test it. They got to build it. And it has to work or they don't graduate. Congratulations, you just spent 4 years at UCF. No, but usually that's very rare that somebody fails that class. But it's designed to bring everything that they've learned in all their courses together in a project-based environment. And then one of the questions that came up in the YouTube chat was, well, what kind of jobs are there? So this first column, these are companies that you recognize. They are companies that are big and small, very popular, and they sort of are bringing all the components together in a device like an iPhone or a computer, or things like Corning. You know, you've heard of Corning. They're actually making the glass for the iPhone. And then you see these other companies, many of which you probably don't recognize. And these are the ones that are building the core components that are used in the larger products. So big and small, our students can go either to small companies or to very large companies. I think one of the other questions that I heard there was about, was the kind of jobs. And then I had a question that was emailed this morning about how do I make sure I don't lose my job in the future? So I don't know how you would prevent yourself from losing the job in the future, but I'll say this much, is that you must be a lifelong learner from beginning to end. And that the way to help insulate from losing your job, I mean, this has been extraordinary times, and so people have lost their jobs through no fault of their own. But some way to insulate that is become as educated as possible, to know as much as you can about the field, always volunteer, so that you move into a place where, you know, you become valuable to the company. So when you graduate, whether from high school or, you know, UCF or any other school, is to always be a lifelong learner. So with that, what I'm going to do is I'm going to bring in Brandon Triplett, who is one of our students in the major, and I'm going to stop sharing the screen here. Okay, Brandon.
Hi.
Okay, so Brandon's one of our students, and go ahead and I guess introduce yourself, and if you've got anything that you want to say, hey, here's what I do in our program.
Yeah, well, we're mostly going to do a question and answer format today. I know you have some questions prepared for me, but I'm a senior here at Creel. It's been 4 years now. I've taken almost all the courses. I've worked 2 part-time jobs at Creel. I've done research in 2 different groups at Creel. I'm now employed by Lockheed Martin, where I happen to work, like we work as a team with Creel. And overall, I've seen a lot of the different aspects of Creel. I could probably answer a lot of your questions from like a student's perspective who's almost done now. So any questions, throw them at me.
Okay, so here's the question. So how difficult have you found the degree to be?
That's a good question. Well, it's supposed to be difficult, as you would expect, but what I've found is that in hindsight, now that I've taken all the courses, it shouldn't have been so difficult. And that's true for a lot of things. But what I've really felt is that I've truly learned a lot. And as I progressed through the degree, it got a lot easier towards the end, actually, when the classes were supposed to be harder, because I spent the first half of the degree honestly struggling so much that I was forced to get better. And so to answer your question, it's difficult, but
what do you
worth it.
Yeah, what did you see as the primary difference in the way that you studied between high school and college?
Oh, I had to actually study. I mean, a lot of students in high school are kind of conditioned to being able to get away with studying right before the day of the test, and it doesn't work in college. You have to really actually understand what you're working with. Like you can't lie about not knowing the subject. You'll get the grade that you deserve.
Okay, and then tell a little bit more about the experience that you've had at Lockheed and how you ended up getting that position, and generally what that's about, because I think it's a little bit of an exclusive program that they've got.
Yeah, I got that job a lot by chance, but I had nothing particularly special about me when I got that job. It's just that everything happened to align for me to get it. But one thing that my boss at Lockheed liked that I had done is that I had tried really hard to get a part-time job at Creel, even if it was for the job that I was going to get into. That job was kind of menial compared to that. It was just mostly cleaning up laboratories at Creel, but I made it very clear that I was interested in what I was doing, and I made it very clear I was willing to accept any opportunity that came my way, and for me that happened to be all it took to get a job there. But as for what I do, we work in conjunction with MIT and UCF to create metasurface optics, which is, as Dr. Delfyett was describing earlier, there's different fields or different areas of study in this field, and that happens to be the material side. So.
Okay. There's a question from Jeffrey Hancock, who's in the YouTube chat. What math courses did you take in high school?
So I did early admission, actually. So I didn't do my senior year in high school. I went straight to basically what is dual enrollment, but full time. But if I can turn this question into some sort of advice, I'd take AP Calculus if it's possible. Definitely. My biggest roadblock to starting this degree was calculus. It's, to me, maybe I'm a bit biased because I struggled with it, but it's the most important foundation class to any engineering degree. I would invest as much time as I can into that class to make sure you really got it, you really know it. So take AP Calculus, take whichever whichever way is going to be the most genuine experience for learning that subject, which I think AP Calculus does a good job. Like I said, I didn't take it. I went the pre-calc route and then to, actual calculus one my freshman year. But I think getting an early start in high school with AP Calculus is a great idea.
Okay. And then, let me ask you this, because, UCF is big. Did you know that we're big?
Yeah.
And we had what, pushing 70,000 students this year. So can you talk a little bit about the college versus the university and sort of the environment?
It's honestly one of our most favorable talking points is that we're a small college. You get to know everyone, especially the faculty and staff, and that's an incredible benefit compared to other colleges where they probably won't know your name, and especially when we got a lot of questions about like job security and stuff like that. With such a small college and a good demand for engineers in this field, like the numbers all work in your favor and incredibly well. You're like I said, for the questions about concern about job safety, our small numbers work in our favor big time.
Okay.
And even they work even well. Excuse me. It's even nicer for the actual college experience with all your teachers. Everyone knows each other.
Yeah, we're a little different because we're actually a small college that's right now we've got 160 undergrads, and we've got how many grads? I would say 150, 160, 170. So we're fairly small compared to some of the other programs. So, if you're worried about coming to UCF because you don't like a big university, we have really something that is small within a large university. So you've got all the benefits of all the resources that go with a large university. There's tutoring services. There's a phenomenal student health center that's on campus. The food's pretty good at the cafeterias. And but then we've got this small environment where we get to know the students well, and the students get to know us. So it sort of helps navigate the complexities of a very large university.
Yeah, you got the best of both worlds there. And it's
and then another question from the Invisible Squid in YouTube. Besides physics, are any other sciences needed as prior knowledge? What would you say?
Prior knowledge, no, but you're going to explore a lot of fields, especially electrical engineering, which, as Dr. Delfyett tried to hint towards, they're very intertwined, photonics and electrical engineering. Electrical engineering is the big one, but you don't need prior knowledge. Physics pretty much covers it.
Yeah, probably the big thing is that you hear this all the time. You gotta have time management, right? And I know that out of high school, in high schools, the teachers control all aspects of your life, especially if you're an AP or IB, where the teachers are, they'll schedule you. You've got to come to a separate Saturday study session, and so everything's controlled. And then when you get to college, that control drops off dramatically. So, it's about really scheduling everything that you've got going on so that you stay on top of things from day one. Because really the most important thing is the GPA matters, just like GPA coming out of high school matters so that you can select a college. Well, that GPA is going to matter because it's the way that companies can judge what kind of knowledge you have. And so what I say is, with a high GPA, you get to pick the company. With a low GPA, the company picks you, and it may not be in a place or location you want to be, but you'll still get a job, especially if you're in photonics. Okay, so let's take this out to everybody, to Peter, Brandon, stay on, and then Dina, if you can come back in, and let's go to any questions that anybody might have. And if there's anybody in Zoom, we've got about 5 minutes left. And So a question also from the Invisible Squid is, do companies reach out to students prior to graduation?
In my particular case, I've been working with Lockheed so long, I've just had communication with them. I haven't had anyone reach out to me, but I also haven't made a single effort to look for a job because I have one. I don't know if that question was for me or not. But.
No, it's great. Yeah. I actually had one student that got a job two students that got a job 9 months before they graduated. And they were seeing starting salaries at about $70,000 a year. That was here in the Orlando area.
Yeah, that's about right.
Yeah, we're seeing those averages pretty consistently. Dina, we got a question for you. Just to confirm this, does the Bright Future Scholarship guarantee a spot at UCF?
So it does not. The only thing that guarantees admission to UCF is either transferring from a Direct Connect institution or being a part of the Top 10 Nights program.
Okay. And Gabriel is asking this, I think this might have been asked, would dual enrollment students follow the freshman application process or the transfer application process?
I'm sorry, could you repeat that one more time?
It was, do dual enrollment students follow the freshman or transfer application process?
So if you're currently dual enrolled, you would still follow the freshman application process. You wouldn't apply as a transfer student unless you have graduated high school already and completed 12 credit hours after high school graduation.
Okay. And then a question from Ashton. How would you say what you learn in photonics, how is that comparable in other fields of engineering, and how easily would it be for someone from a field like computer science to transfer? Peter, I got an answer. I'll
Sure.
toss.
So how about this? I mean, I think if you take a look at all of the engineering disciplines, most of the students which are coming into, whether it's computer engineering, computer science, mechanical engineering, etc., during the first 2 years of their coursework at UCF, they're primarily focusing on classes such as calculus, differential equations, physics, etc. So the core courses that a lot of the pre-engineering students are taking, are identical. So if you're literally in your sort of first, 2 years or so at UCF, where you might have been embarking upon a computer engineering or computer science degree, the core coursework that you'd be taking there would overlap nicely with the coursework that's required in the photonics degree at UCF. So it would certainly be easy to do the transfer. If you're sort of, in your third or fourth year of computer science and you want to say, gee, let me do photonics, there would certainly have to be a number of additional courses that you'd have to take in order to get the photonics degree. So as long as you're, sufficiently early on, let's say not more than halfway or 2/3 of the way through, the transfer should be reasonably seamless.
And then got another question for you. Johnson's going to ask that now. He's in here with us in Zoom.
Thank you, Mike, for the opportunity. I'm from Kenya. Now, my question is, I have an MSc in physics, and my research was in applied optics and lasers. Now, my question is it possible to apply directly to the PhD program in optics and photonics that is offered at CREO?
Yeah, that, if I can handle that, and Mike, you can pipe in. So how about this? Most students which are coming into the graduate program, at Creole are coming in with a bachelor's degree either in electrical engineering or physics, just because, there are not that many institutions across the globe that have sort of an optics or photonics degree. So most students coming into the program are in fact, double E's or physicists. So it is definitely possible if you have a background like yourself with a Master's of Science in Physics, you can definitely directly apply to the PhD program in optics. No problem about that.
Thank you. I'm answered.
Okay. Well, it looks like we're just about out of time. So I want to give a couple of announcements. Thank everyone. First of all, check out our website, photonics.creole.ucf.edu. And that's creol.ucf.edu. And then also just check out on May 16th, the International Day of Light. They got a lot of stuff going on. They've got a photo contest. So you can find out about the International Day of Light, May 16th, and find out why it is on May 16th. And then finally, I just want to thank Peter and Brandon and Dina for helping us out. And also for everybody that joined us, and feel free even beyond that to contact us if you've got any questions about the Photonics program or even coming to UCF. So thank you all, really appreciate it, and have a good rest of the day.
I put my email in the Zoom chat if anyone wants to email me a question as like something you want to ask a student.
Great. And then I'll put that over on chat. So everybody on YouTube, bye-bye.
All right.
Bye, guys.
Bye, everyone.
Okay, we're off there.